It was totally unlike any other path, any other trajectory, any other orbit in our solar system.
Oumuamua, the mysterious space object first observed in 2017, has baffled scientists once again with its unexpected return to our solar system. Moving at an even faster pace than before and following an unusual trajectory, it's sparking concerns among researchers.
This was not some solar system object falling from a long way away. This was something that came from another star, and I think everybody was pretty amazed by that.
The object's origins remain a puzzle, and its reappearance raises questions about its potential impact on Earth. Join us as we explore the mysterious nature of Oumuamua's strange behavior and what it could mean for our planet. The feared return of Oumuamua. After more than 6 years, Oumuamua has come back into our solar system, and this time, it's heading directly towards Earth. Scientists are again on the hot seat, trying to figure out where it is from, why it's moving at an unusual angle, and how it's speeding up without a glowing tail like most objects. Most scientists agreed in 2019 that it's a natural object, but we're not exactly sure what it is because they have not studied it for a long time.
Sadly, no emissions were detected. It's almost certainly a natural object. I would bet all of my money on that.
Some researchers suggested that it could be a bunch of rocks stuck together, like a rubble pile, while others believed it had some icy parts, making it less dense. Nevertheless, its origin remains unknown, and there are different ideas about where Oumuamua comes from in the scientific and astronomical fields.
This thing came from interstellar space into our solar system, and the main question is, what could it be?
Could it be the remains of a broken comet, or a piece of a faraway planet with ice, similar to Pluto? In March 2023, scientists suggested that the unusual speeding up might be because of gas released from an icy body, making Oumuamua similar to comets from our solar system. Harvard University astronomer Avi Loeb, part of the Breakthrough Listen project, suggested that Oumuamua could be something made by aliens.
I was disappointed. I would have been much more excited if we have found evidence for an alien civilization.
In 2022, some researchers talked about a plan called Project Lyra, where we could send a spacecraft to catch up with Oumuamua in 26 years to study it up close. But the mission was not followed through. Once again, the scientific world is ready to explore this strange object. The behavior of this mysterious object puzzled scientists enough in 2019, but the fact is, it had shown up previously in 2017, leaving scientists scratching their heads. Cruising through our solar system. Oumuamua is a special interstellar object because it's the very first one from outside the solar system that's been seen passing through. It was found by using a telescope in Hawaii in October 2017, about 40 days after it got closest to the sun. The object is not very big, maybe between 100 and 1,000 meters long, and it's estimated to be red, like things in the outer part of our solar system. Even though it got close to the sun, it didn't have a glowing tail like some objects. It also moved in a way that wasn't normal, possibly because of gas escaping from it or being pushed by sunlight. Oumuamua spins like asteroids in our solar system, but it might be more stretched out than other things we know. Its movement makes scientists think it's likely from outside our solar system. It's on a path that will take it out of our solar system and into space between stars. We are still determining where it originally came from and how old it is. When it was first discovered, it was called a comet, but later, it was called an asteroid because it didn't have a glowing tail like comets usually do. Since it comes from outside our solar system, it has a special name, 1I, the first interstellar object. People can call it 1I, 1I/2017 U1, Oumuamua, or 1I/2017 U1. The name Oumuamua isn't just some random name. It's a way of showing respect to the Hawaiian people for the role they played in the discovery of the island. Even though Oumuamua is from outside our solar system, it didn't show any unusual signals when observed with radio telescopes, and scientists couldn't find any signs of it being a spacecraft. It's an exciting object that has sparked curiosity among scientists, but there are some weird things about this mysterious space object, the distinct nature of Oumuamua. The mysterious space guest seems to have come from the direction of Vega in the Lyra constellation. Its path into our solar system was at an angle of 6 degrees from the solar apex, which is the direction of the sun's movement compared to nearby stars, a common path for objects from outside our solar system. Some observations from the Catalina Sky Survey found its hyperbolic trajectory, meaning it's on a path that won't make it orbit the sun. This space rock zoomed through our solar system quite fast, and its speed changed a lot during its trip. When it was about 2,300 astronomical units, it traveled at 26.41 kilometers per second, showing it was already moving pretty fast from where it came, outside our solar system.
At a very high velocity into our solar system, and the velocity was so high that it proved that the object was actually coming from the outside. It was coming probably from other solar system and was just passing in.
As Oumuamua got closer to the sun, its speed stayed steady. At 1,000 astronomical units, it was still going at 26.42 kilometers per second, proving it could keep a consistent pace across big distances. When it got closer to the sun, around 100 astronomical units, its speed increased to 26.73 kilometers per second, probably because the sun's gravity was starting to affect its path. The most significant speed change happened when Oumuamua entered the inner solar system. At 10 astronomical units, it sped up to 29.56 kilometers per second, showing that the sun's gravity was having a big impact. When it came close to the sun at 1 astronomical unit on August 9, 2017, it raced at an incredible 49.70 kilometers per second, proving its dynamic and fast journey. On September 9, 2017, at its closest point to the sun, the perihelion, it hit its highest speed, reaching 87.71 kilometers per second. After that, as it moved away from the sun, its speed gradually slowed to 49.70 kilometers per second at 1 astronomical unit on October 10, 2017. As it moved away from the sun, heading toward the Pegasus constellation, it continued to slow down until it reached the same speed it had before entering our solar system. Scientists believe Oumuamua stayed in our solar system for about 2 months. By studying how it moved and how fast it went, they discovered that Oumuamua came from outside our solar system, probably from near another star. Scientists shared that Oumuamua had a speed boost that wasn't because of gravity. They thought it might be due to sunlight pushing it, a force called solar radiation pressure. This change in speed, as mentioned earlier, happened when Oumuamua was close to the sun. The Halley telescope observed Oumuamua on October 25th and saw it had a red color, like comet nuclei or Trojans. Later that day, the William Herschel telescope showed that Oumuamua was featureless and red, similar to objects in the Kuiper Belt. The Very Large Telescope confirmed this in near-infrared wavelengths, revealing a spectrum like D-type asteroids. Unlike most objects, Oumuamua doesn't spin around one axis. It tumbles unusually. This tumbling may be due to a collision in its original system, which continues tumbling for a very long time, maybe 1 billion years. The variations in its brightness suggest that Oumuamua could be shaped like a long cigar or an extremely flat object like a pancake. However, we haven't directly seen Oumuamua's size or shape because even in powerful telescopes, it appears as just a point of light. If it's shaped like a cigar, it could be 5 times longer than its width. Assuming it reflects only 10% of light, Oumuamua could be roughly 100 to 1,000 meters long, with an average diameter of about 110 meters. Some scientists think Oumuamua may be made of dense, metal-rich rock, reddened by cosmic rays over millions of years. Tholins, irradiated organic compounds common in the outer solar system, may be present, giving its surface a reddish color. Although it didn't show a comet's tail when near the sun, Oumuamua might still contain hidden internal ice, protected by a mantle formed from cosmic ray exposure. In November 2019, some astronomers suggested Oumuamua could be like a cosmic dust bunny made of lightweight dust and ice grains. In August 2020, it was confirmed not to be composed of frozen hydrogen, but its exact composition remains unknown. While its exact composition is unknown, and will probably remain so for a while, even its origin is a question that scientists have yet to find an answer to. Breaking down, the uncertainty of Oumuamua. Considering how fast Vega is moving, it would have taken Oumuamua about 600,000 years to travel from Vega to our solar system. However, Vega was in a different part of the sky at that time. Scientists estimate that 100 years ago, Oumuamua was about 83.9 billion kilometers away from the Sun, traveling at 26.33 kilometers per second. This speed matches the average motion of things in our Milky Way, suggesting Oumuamua likely came from outside our solar system. It may have circled the Milky Way several times, possibly originating from a different part of our galaxy. We need to find out how long Oumuamua has been traveling in space. Our solar system may be the first planetary system it has encountered since being thrown out of its original star system, which could have happened billions of years ago. Some theories suggest it might have been ejected from a system with a white dwarf or from one of the local groups of young stars. There's also speculation that Oumuamua could be a fragment from a broken-up planet, making it a rare object. In 2020, some scientists suggested it might belong to a group of icy bodies formed in giant molecular clouds, but later calculations raised doubts about hydrogen icebergs surviving such a long journey through interstellar space. The mystery of Oumuamua's origin continues to puzzle astronomers. Since our space guest is so mysterious and puzzling, people have come up with a simpler explanation, associating the interstellar object with aliens. This first interstellar traveler, which has raised many questions since it was discovered, differs from other known objects of celestial origin. It has unique features that set it apart from typical celestial objects. At first, there were just two speculations regarding the nature of the object. The first was that it was an asteroid, and the second was that it was a comet. However, scientists have cleared up that doubt and clarified that it is not an asteroid. This results from its elongated shape and rapid rotation, unlike an asteroid. Also, its brightness fluctuated significantly as it traveled through space, and this indicates that it has a non-uniform surface. When mankind cannot find an explanation for a phenomenon in one way, they look for other ways to explain it and satisfy their curiosity. Within the scientific community, these anomalies depicted by Oumuamua raised a lot of eyebrows, and since they could not be explained using conventional means, it prompted some to consider alternative explanations for their existence. These include its possible extraterrestrial origins. Of all the facts that could point to the extraterrestrial nature of the object, perhaps one of the most compelling arguments for the extraterrestrial origins of Oumuamua is the unexpected and unexplained sudden acceleration experienced as it passed through our solar system. It was traveling at 54 miles per second. Okay, that's seriously insane speed. Why did it suddenly pick up speed when it was passing through our solar system? Why didn't it maintain the same speed it had been traveling before? If it wasn't a living thing controlled by a living thing, how could it determine its speed? There are many questions, but science needs help finding generally acceptable answers. Scientists still need to be more knowledgeable. Even so, there are no satisfying explanations regarding the acceleration. It could not be attributed to gravitational forces alone, and this has led astronomers to come up with the hypothesis that it might be propelled by solar radiation pressure. The problem here is that, though this phenomenon is not unheard of, it is possible for something to be propelled by solar radiation pressure. However, the magnitude and speed at which Oumuamua accelerated was just too much. It was far greater than expected, and of course, it had further increased the number of questions about its true nature. Another intriguing feature that created even more question marks is that it has been dubbed a comet, since it isn't an asteroid. However, a comet is supposed to have a visible coma or tail when it approaches the sun. But with Oumuamua, it was the complete opposite. The visible coma or tail, which is typically associated with comets, was absent. As to what a coma or tail is, when comets approach the sun, they release gas and dust, creating a visible tail. Our space guest, however, defied that motion and remained devoid of any such cometary activity. This peculiar feature, which is a departure from the norm, adds fuel to the already burning fire surrounding the likelihood that it could be an artificial object that was designed to withstand the harshness of interstellar travel. Of all the arguments for the possible extraterrestrial origins and nature of Oumuamua, the most fascinating one has nothing to do with its size or shape, but is about its intergalactic trajectory. The space object holds the record for being the first known interstellar object to pass through our space. How does this concern extraterrestrial activities? Scientists have clarified that the likelihood of a naturally occurring intergalactic object entering our solar system at the right trajectory to be observed is maybe 0 points or something percent, because the chances are extremely low. However, this Oumuamua entered our solar system at the perfect trajectory to be observed, even though it moved at an insane speed. This is why some supporters of the extraterrestrial hypothesis propose that the object could be a probe, or maybe even a spacecraft sent to monitor Earth by an advanced alien civilization. If it turns out that Oumuamua is of alien origins, its possibilities would simply be limitless. It would represent a very significant discovery, one of the greatest, if not the greatest, discoveries of mankind. It would have profound implications for our understanding of the universe. Man is a curious being by nature. The possibility of an advanced alien civilization capable of intergalactic travel raises many questions about the scope and advancement of their technology and their motivation. But again, the possibility of Oumuamua being of extraterrestrial origins is only one of the theories about its real nature, and scientists aren't willing to accept it. So they've raised other theories about it. What do the scientists know about Oumuamua? If there is one thing scientists are not fond of, it is being clueless. It is obvious that the theory of Oumuamua being an alien probe or spaceship is the most captivating, and it captured the imaginations of the public, keeping them on the edge of their seats waiting for the next news. However, knowing the implications, scientists have used a very cautious and methodical approach. Their search for natural explanations for the strange object continued. One of the natural explanations they came up with is the theory that Oumuamua is probably just a fragment of an asteroid or a comet, meaning that the object originated from a larger celestial body within another star system. It is important to note that it is common for comets and asteroids in the vast expanse of space. According to scientists, comets and asteroids ate the remnants of the early formation stages of planets. They are made of rocks, metals, ice, water, and various compounds. On a side note, it's surprising that asteroids have water and ice. When these asteroids and comets collide with one another, or other space dwellers, they often break into smaller fragments, from which our space guest, Oumuamua, is believed to have originated. It is believed to have come from a much larger comet or asteroid, and something, maybe a collision, caused it to fall apart from this larger object. It then traveled through space and ended up in our solar system. As to why it didn't release gas and leave a trail when it was approaching the sun, they explained that the gaseous substances that would have caused outgassing were already depleted or located in the object's sealed interior. Another natural explanation proposed to explain the unique behavior of the object is what is known as the solar sail hypothesis. The theory suggests that Oumuamua could be a flat and thin object, a few meters wide and less than a milliliter in thickness, so it looks a bit like a sail. This structure would therefore have a highly reflective surface, so when it passed close to the sun, it would be subject to its intense radiation, and as sunlight photons hit the reflective surface, they impacted it with a tiny amount of momentum. When countless photons hit simultaneously, they can cause the solar sail to accelerate and deviate from a purely gravitational trajectory. If this theory is true, it would explain why Oumuamua suddenly sped up when it passed through our solar system. The solar sail theory is quite interesting, as it addresses all the issues surrounding our visitors. Another interesting thing about the theory is that it would not produce a visible comet-like tail, as there is no outgassing of volatile materials. Instead, the push is generated through the reflection of sunlight. However, the solar sail theory has its challenges.
Is the latest in a series of tests of a new type of propulsion system called a solar sail.
While it is very intriguing, it does come with its own constraints. One of the biggest challenges it faces is that it needs an explanation of Oumuamua's rotation, shape, and tumbling motion. These features would need to be explained in the context of solar sails. Also, it needs to be clarified how a solar sail of such dimensions could maintain its structural integrity under the enormous stress of interstellar travel. Seeing the shortcomings of the solar sail theory, another theory emerged, called the hydrogen iceberg hypothesis. This theory suggests that Oumuamua could be a celestial body composed of frozen hydrogen, because hydrogen is the most abundant element in the universe and can exist in a solid state at extremely low temperatures and under pressure. Thus, this theory suggests that Oumuamua might have originated from a freezing, distant region of its home star system. In that environment, hydrogen could have frozen into a solid, forming a dense and compact object. If this hypothesis were true, and Oumuamua is indeed composed of hydrogen, it would have a very low temperature, probably close to absolute zero, explaining why it left no cometh-like tail as it approached the sun.
It's dark. This means it's about half a mile long. Nothing else in our solar system looks like this.
So how did the hydrogen accelerate Oumuamua? According to this hypothesis, the acceleration is attributed to the object's interaction with solar radiation. This means that although hydrogen is transparent to visible light, it can interact with higher energy ultraviolet and X-ray radiation. The absorption and remission of these high-energy photons could generate a thrust. The thrust is small but consistent, and it causes the object to accelerate. If this theory is confirmed to be true, and Oumuamua turns out to be a hydrogen iceberg, it would be a peculiar and extremely rare object, as such formations are not easy to come by. It would also explain its distinctive features and why it stands out among known celestial bodies. While Oumuamua is the first interstellar object ever seen in our solar system, it's not the only one. Another object appeared in the very same year of Oumuamua's reappearance. Our strange visitors from outer space. Comet 2I/Borisov is the second interstellar object and the first confirmed interstellar comet. It was discovered by Crimean amateur astronomer Gennady Borisov on August 30th, 2019, and quickly became a global phenomenon. After a week of observations by amateur and professional astronomers worldwide, scientists determined the path of the fleeting visitor and confirmed it came from outside our solar system. NASA's Hubble Space Telescope captured images of Comet 2I/Borisov in October and December of 2019 as it streaked through our solar system at a breakneck speed of about 177,000 kilometers per hour. The images showed a lot of dust around a bright nucleus, though the nucleus itself was too small to be seen by Hubble. In March 2020, scientists using Hubble noticed a distinct change in the comet's appearance. Instead of the single bright inner core spotted in previous images, the images indicated a fragment had broken away from the nucleus. Scientists will continue to use Hubble to monitor the comet. Only one other visitor from another solar system has been spotted, an object officially named Oumuamua. It passed within 24 million miles of the Sun in 2017 before racing out of the solar system. Scientists still aren't certain whether Oumuamua was an asteroid, a comet, or perhaps a hybrid of the two. Whereas Oumuamua appeared to be a rock, Borisov is active, more like a normal comet. It's a puzzle why these two are so different, said David Jewett of the University of California, Los Angeles, UCLA, leader of the Hubble team that observed the comet. Other comets come mostly from two places: the Kuiper Belt, a donut-shaped region filled with icy bodies beyond the orbit of Neptune, or the Oort cloud, the most distant region of our solar system, beginning with some 100,000 astronomical units, and the AU from the Sun, which contains billions of comets orbiting in a spherical shell. 1 AU is the distance between the Earth and the Sun, about 93 million miles or 150 million kilometers. Comet 2 Y/Borisov is estimated to be about 3,200 feet across, or about the length of 9 football fields. It's rapidly moving away from our Sun and will eventually head back into interstellar space, never to return. The Sun's gravity is slightly changing. Comet 2, I/Borisov's trajectory, but it cannot capture it and pull it into orbit because of the comet's path and its high velocity of about 177,000 kilometers per hour. Observations by NASA's Hubble Space Telescope revealed that the heart of the comet is a loose agglomeration of ice and dust particles. In March 2020, astronomers using Hubble saw indications that a fragment had broken off the comet. Follow-up observations using Hubble are planned. Comet 2I/Borisov formed in a different star system than our Sun and its family of planets. It could be much older or younger than our 4.5 billion-year-old family of worlds. Many comets that originally formed around our Sun have been ejected from our solar system, mostly due to gravitational encounters with Jupiter. Thus, it's conceivable that Comet 2 Y/Borisov might also have been similarly ejected from its home. We have no direct observations of Comet 2 I/Borisov's surface, but comets from our planetary system have rough surfaces coated in places with smooth blankets of icy, dusty debris. Comet 2 I/Borisov is too small to hold onto its atmosphere. It doesn't have enough material or mass, and thus not enough gravity. However, like most comets that venture closer to the Sun than Jupiter's orbit, Comet 2 1/Borisov developed a coma, a dust-filled cloud of gas around the comet's nucleus, created when ices are warmed by solar heating and loft fine dust off the comet's surface and into space. Thank you for watching. Comment to share what you think in the comment section below. Remember to like and subscribe to see more videos.